Hello everyone. So let's start LR0 parser. Before starting LR0 parser, remember these points. The point is for every parser, whether you take LL1 parser, LR0 parser, SLR1, LALR1 and CLR1, all these parsers have three things in common. One is the stack, second is the parser, and third is the input buffer. The only difference between each parser is their parsing table. So parsing table is different in each parser. And while discussing LL1 parser, we learn first and follow to construct LL1 parsing table. Now this time we learn LR0 and SLR1 parser. Okay, these two parsers require, or even LALR1 and CLR1, all these four parsers required action and goto. Okay, what is action? Action is act upon the terminal part. Okay, means whenever we see a terminal, then we can shift it to the stack, and goto is nothing but the variable part or non-terminal, and it means that we reduce a particular variable to a terminal. Okay, so we need to know two concepts while solving LR0, SLR1, LALR1 and CLR1 parser. First is the action part and second is the goto part. So action and goto is present in all this parsing table, whether you construct LR0 parsing table, SLR1 parsing table, LALR1 parsing table or CLR1 parsing table. Okay, but these two parsers LR0 and SLR1, in previous video I told you, require LR0 item, canonical collection of LR0 item, and these two parsers require canonical collection of LR1 item. Okay, so first we learn canonical collection of LR0 item, and then after we learn canonical collection of LR1 item. Okay, so let me take an example. The examples which I have taken in LL1 parsing table also, same example I have considered it again. As derive small a, capital B and small a. Okay, then capital A derives capital A, B, C or simply B, and capital B derives small d. Okay, so this is the grammar, and for this grammar I need to know the canonical collection of LR0 item. So what is LR0 item? LR0 item, any production. Let's say I have take this production as derives AABE. So while starting LR0 item, so I need to first put a dot in the leftmost side of RHS, and after that all these symbols are came together. It means that we have not seen anything in the right hand side of this production, and eventually this dot will move one after the other at every in the right hand side portion. Means it can go as derive A dot capital A, capital B and small a. It means we have seen small a in the right hand side, and we want to whether we want to reduce or whether we want to change, does not anything here. Similarly, this dot part will move right side and again right side, and till this dot will come to end. When this dot come to end, then we can say that eventually at some time this dot, let's say A dot ABE, and then after S derive AA dot BE, and then after S derive AA B dot E, and then finally this dot reaches at the rightmost side of RHS, and when it reaches rightmost side of the RHS, then we can say that this is the final item. Okay, for every production we move the dot till we reach a particular final item. So this is the meaning of LR0 item. Okay, and this whole together, if I put this one in a circle, this one in a circle, and this all circles whole together will called as a canonical collection of LR0 item. Okay, so let's construct canonical collection of LR0 item for this grammar. So in this grammar I have three productions, and in these three productions we have three variables, and how many terminal? 1 2 3 4 5. So total 6 terminals along with the dollar symbol. So total 6 terminals are present and 3 variables are present. So let's construct. So first of all, whenever you take any grammar, you start adding augmented productions. Augmented production will look like this: s dash derive dot s. Okay, and then after seeing dot s, it means that this the production of s will add after this augmented production. So whenever a dot is present before any variable, so that variable production will be considered in this particular LR0 item. Okay, so we will add as productions as derives dot A B E. Okay, so let's draw it here. This is the grammar, and s dash derive dot s, then I will add the production of s dot A capital B. Okay, and for a terminal part we do not add any production because terminal have no any productions in the grammar, only the variable have productions. So this is called one state of LR0 item. Okay, and for every variable we take a goto part, we take a transition, and this transition is called goto transition. And for every terminal we take a transition which is called as a shift or shift transition. Okay, so for s I will take a transition s dash derive dot s. Okay, for a, for small a, I will take a shift move. This is called go to move and this is called shift move. S derive a dot will move after the a part. So capital A, capital B and small a. Because of this a capital A, I will add the production of a dot capital A B C or dot B. Okay, and it is the same symbol a, so no need to add again the a production because you will get eventually the same production of a. Okay, so this is complete. This is the final item. Now we need to add the production of a. Production of a is here a present and here a present, means we add production of s. A derives s derives a dot B E and a derives a dot B C. Okay, so for a it is over, and for B a derives B dot. Understand this? These two productions are different. Okay, it is one production for which I have taken a go to move, and for this production I have taken a shift move, and this is the final item. Okay, for A and for B I have completed this completed the steps here. Now for this production for capital B. For capital B, S derives A B dot E. And one more thing, for this B I need to add, the B productions. So B production is B derived dot T. Okay. And for this B I have taken a go to move. Okay. And eventually after this E, we will reach a final item. S derives AAB E dot. Okay. So it eventually comes to an end. Now let's take the B part. So for B, A derives AB dot C, and for C, A derives AB C dot, and this is the final item. Let's take D move here. B derives D dot, and it is also a final item. Okay, so I think I have covered all the states. Let's check one more time. For S, yes. For A, it is over. Okay, then A will move eventually here. Then for A, I will take this productions. Okay, then for B, I will take this productions. Then after that, for B it is over, and for D it is over. For capital B it is over. Okay, so how many states are here? There are total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 states here. So I will just name them, the states I0, then I1, I2, I3, I4, I5, I6, I7, I8 and I9. So this is called as canonical collection of LR0 item. So in canonical collection of LR0 item, we have total 10 states present. Now after constructing the canonical collection of LR0 item, we need to construct the LR0 parsing table. So LR0 parsing table require canonical collection of LR0 item. Okay, so how we can construct the LR0 canonical LR0 parsing table? So I will draw a table here. Okay, let me erase this portion first. So in table action part, and one more thing, go to part. Okay, and total we have I0 to I9 states, I1, I2, I3, I4, I5, I6, I7, I8 and finally I9. Okay, in action part all the terminals are present. So what are the terminals here? A, B, C, D, E and dollar. Okay, and in go to part there are three variables, capital A, capital B and capital S. Okay, so this is the LR0 parsing table, and after filling the row with the state number and column with the action and go to part, while action contains the terminal and go to part contains the variable, then after that we will fill each row according to the state in canonical collection of LR0 item. So first state I0. I0 have two moves. First is the go to move and second is the shift move. Go to move is on S. So I0 on S go to I1. So on S part I will take here 1. For a shift move, it goes to state number I2. So on shift move on A part, I will write S2. Okay, so whenever you take a shift move, you will write capital S represents shift move and the state number, on which state number on which the particular shift move is going. Okay, now after that, let's consider this I1 state. I1 state is basically an augmented state, means we added this particular production in our grammar. So here I1 means accept, on accept dollar. So after reading the whole input, eventually we will come to the dollar part, and dollar part means it is accepted. Then I2 state will take two move. One is the on shift move on small b. On small b it is going to I4. I4 state means here S4. Okay, on capital A it is going to I3 state. On capital A it is going to I3 state, so I write 3 here. Okay, so I2 state is over. Let's take I3 state. I3 state have 3 moves: capital B, small b and small d. Small d is I7. Small d is I7 means shift 7. No, it is I3. So on small d it is shift 7, S7, and small b it is I6. I6 means shift 6, S6, and on capital B it is I5. Capital B it is 5. Okay, then after that I3, I4 is the final state and final item. So let's consider this production as production number 1. This one is production number 2. This one is production number 3, and this one is production number 4. So for every production I have a number, and whenever we get a final item on any state, then I will write the production number as suffixes with R symbol. So on I4 it is final item, and which production number? It is third production number. So I will write R3 in the entire row, of action part. Okay, then after I4, I5, here I5 is not a final item. So on E part it will go to I8. So E part is here, it will go to I8 means shift 8 over. After I5 let's take I6. It is also not a final item. So on C it will go to I9. On C it will go to I9 means shift 9. Okay, that's over. I7 is the final item, and which production number is? It is production number 4. So I will write R4 in the entire row, of I7. So R4, 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 and finally R4A. Okay, now I7 is over. I8 is also a final item. Which production number? Production number 1. So production number 1 is placed in the entire row of I8. So it is placed under R1, 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 R1 and R1. And now the last state I9 is also a final item, which is production number 2. Production number 2 is placed in the state number 8. R2, 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 R2 and R2. Okay, so that's how we construct the LR0 parsing table with the help of canonical collection of LR0 item. Okay, so how to put the action, particular action and go to part. On action part you need to write either S or R. S represents shift move, R represents reduce move. Okay, for reduce move you have numbering the each production in the grammar. Okay, and for shift move you take the state number. For example, S2 represent the state number 2. Okay, S4 represent the state number 4. Okay, and for I1 state, which we added augmented production, the augmented production always accept at the dollar part, because every input ends with a dollar. And for goto part, while constructing goto, you just write the state number. No need to add state number along with the shift move or reduce move. Just write the state number. Just say for let's say for example 1, 3 and 5. Okay, so this is the LR0 item. In the next video we will see SLR1 parser.